So my clock makes it 2 o'clock, and as is tradition on all of these, we'll give people a few minutes, which means that I will talk about stuff. So the slide on the screen is actually from another talk that I did, I think it was last week, which you'll find if you go onto our LinkedIn page, you can find, and that's talking about change detection. But we're not actually going to talk about that today. Today, we're going to go completely insanely crazy. And I'm going to try and do some demonstration of the Qt Design Studio integration that we're trialing. And I'll just warn you all in advance that this is wickedly alpha to the point of fact that when I updated to Qt 5.15.1 by accident earlier this week, it caused everything to break and I've had to work on it a little bit. So fingers crossed that today will actually work. I can assure you that whatever happens, it will be exciting. You'll probably get to see me embarrassed, flustered, all over the place. And hopefully as a result of all of that, you'll also get to see a machine learning algorithm learning that hello and world go together in the right order. Now we've promised 2 different languages. I'm only going to demonstrate using Qt Design Studio today, but I will also show you a similar thing using Python. It's important to note that what we actually sell is a software library, and that software library is for doing machine learning on IoT devices. Now, this demonstration is interesting in that it is for Qt Design Studio, which is perfectly suited for doing UIs, things like that for embedded devices. And what we're going to show is that you can actually do some simple machine learning tasks, completely drag and drop without actually writing any code at all. And then I'm going to show you just how simple the equivalent code would be in Python. And just, as a reference, the C++ API, which was what I used for the change detection demo, is exactly the same as the Python one, except with different naming conventions, because camel case is not such a thing in Python. We have to use underscores instead. So, all of these tie together fairly well. They're all pretty straightforward and easy to use. And I think we should just chuck into it. Now, I have another slide here because that's important. Talking about the rules of engagement. So this is basically saying how to use Zoom. I'm pretty sure everyone on here has used Zoom at least once in the last 6 months. And if not, welcome. There's a chat function so you can send messages. They will hopefully pop up on my screen. If you have questions, same thing, use the Q&A function. If you want to comment, wave your hand. Don't actually know what that does, so I'm quite looking forward to seeing that. And, you're all muted, so if you want to laugh at my crazy drag and drop mistakes, that's totally fine by me. I will never know, which means I won't feel any extra pressure. Right, let's get out of PowerPoint because it's like my least favorite tool, and let's go to something a little more interesting. So what we're starting off with is Qt Design Studio. Qt Design Studio is a tool for doing layouts and coding and anything that you want like that. So there's some really great demos on here on the internet showing how you can integrate it into Photoshop and how you can export all of your elements directly into the display. I'm absolutely useless at doing anything visual, much better at writing code. But what we're going to show you here is our blank page. And I'm going to put a couple of buttons on it, one for hello and one for world. And we're going to drag and drop a random forest machine learning model onto the page. And we will associate those buttons with the model, and then we will get it to predict what button should come next. And as long as I press hello, it should say the next button will be world, etc. And then I'm going to show that as it's learning all the time, if I change my pattern, it will also start to change the pattern. So pretty straightforward little demo. So we'll start by explaining what we've got in the different displays. The first thing we have on the left here is a library, and this is showing the different installed plugins. You can see that I have our Ekkono AI library imported as an import here, and that adds these into the pane. Now, different things for different places, but this online model is a template which sets up various different elements from here. So we're going to start by putting that onto the page. Save the file, which will make it go. Now, this is a little slow when I'm running with Zoom, so my apologies. My little MacBook Air is possibly not up to the task of doing development and Zooming at the same time, but I'm going to give it a shot. So you could see in the navigator view here, which is a tree view of all of the components, that it has added an Ekkono item. And when the colorful spinny wheel goes away, I'll expand that and show you what's in it. And in here we have a random forest. We have an evaluator, which is for getting the error. We've got a pipeline, and the pipeline contains, at the moment, 2 sample attributes. So in Ekkono land, the pipeline is where you would put all of the different attributes that you're doing a prediction on. So we will build that pipeline so it has some view of the history. But let's start out with naming our first one. This is just going to be input because we're only going to have one input, and that's what button is pressed. And we're going to call it input. And we're going to say that when this value is set, when a value is written to this, that it should do a prediction. This is a optimization on our standard API, but it works really well in the user interface. As I said, it is quite slow. So we're going to delete the other one because we don't actually need it. The next thing we're going to do is we're going to tell the model what we're actually wanting to target. So you can see here, these are the, if we wanted to automatically stop training, we want to predict one press in advance. So the target horizon is how far in advance we want to predict the value. We want to predict the value of input, and we want the model to start off in the running situation. Okay, fairly straightforward. We don't need to change any of the model parameters for the random forest or the evaluator. We could if we wanted to tune it. You can see this is the hyperparameters for the model, and you can adjust them. They all have a bit of information explaining what they are and how to use them, and that directly matches our API. But what we actually do want to do is we want to say your input depends a bit on your previous input. So we're going to add a lag, which is saying, which is the same value, but in the past. So we're going to say a lag, and we're going to tie that lag to input. And we're going to say one value in the past. So this, that when it goes into the model, all of these parameters go in at the same time into a model, and then the prediction is based on that. So this is saying, take the current value and the value of the previous current value, which is a lag of 1. We're going to do 3 of those, which says your inputs will be based on the previous 3 inputs. And we'll just increase the number here. So all of them are tied to input. So now we have a lag of 1, a lag of 2, a lag of 3. We're just going to add a backwards moving average. And this is saying, well, you probably have a fairly consistent number of inputs. So we're going to say, let's make this average over 5. And we're also going to tie that to input. So that means the model will also do its prediction based on your average over the last 5. So if you're trending one direction or trending the other direction, we'll be able to pick up on that. Now, to simplify our programming, we have this operator called recast that we can add in here. And this is basically a way of managing the output values of the model. These models, they take floating point inputs and they produce floating point outputs, which means that as the model is learning, the number it will produce will be either 0 or 1 or somewhere between the two. So we actually need to make this a 0 or 1. So we're going to tie this directly into our model, the predicted value of our model, okay? But we're going to reduce the decimal points because we don't actually need any detail. All we want to have is for it to be a number 0 or 1. I'm just going to call that rounded. You see it has different operations, but actually we don't need any of those. So the next thing to do is we're going to start by dragging a button onto our screen. And this we're going to call button 0. So as you can imagine, it's going to send a 0 into the model. We're going to, because we're doing hello world, aren't we? We're going to change what it's called to hello. I'm going to do the same with another button. It's quite nice that it snaps them. It makes it a whole lot easier to make it tidy. And we're going to make this one world. So now we have 2 different buttons, button 0, button 1. They haven't been tied to the model yet. So what we need to do is we need to tie them. So we're going to go down to this connection view and we're going to connect the press of button 0. So when on click is done, it actually updates our input. It'll come in a second. we will use this to update the input value to be equal to button 0, which is 0. So basically the model will treat 0 as hello and 1 as world. So we do the same thing here on button 1. So now when you click those buttons, it will put a 0 or a 1 into this value here, into this field here, the input value. Notice that we had predict on set checked, which means that when we write to this attribute, it will cause a prediction to occur. The predicted value ends up in the Ekkono object, ID Ekkono, as the value predicted. We have tied that value into this recast operator under the name rounded. We've tied that to the source value here, Ekkono.predicted. So this rounded.value will pick up the value of Ekkono.predicted. But let's actually display that on the screen. So this is a text, and we're going to change this text. We're going to set binding, and we're going to do rounded.value. And if it's 0, it's going to be hello, and if it's 1, it's world. So the first value will be is world, the second value is hello. So if it is true, then world, otherwise hello. Exactly the same as you would find in C or C++ or something like that. I guess it's staying there. And we only want to show this when we're actually ready, when we actually have a prediction. So we're just going to tie this back into the model, and it has a first prediction value here. And that says, if a prediction has been made, then display that. So if it hasn't been a prediction yet, it will be hidden. So you can see here it's hidden. That's because no prediction has been made. And that's basically it. So let's just have a quick walkthrough here. We have our model, we have target attribute. Yeah, we're training and we're running. Default values on our actual model. We'll use the evaluator later. We have a pipeline which takes an input value. We have 3 lags which are tied to that value, which are the previous 3 buttons that you've pressed. And then we have an average over the previous 5 buttons that you've pressed. And then we will round that number to 0 decimal points, and we will use that to display the text on the item here. Fairly straightforward. Let's save it. And then we are going to do a run. It's spinning because I saved it. That will be back in a second. Now, this is running as QML. So what we've actually generated is QML, and I will show you that in a second, particularly if it doesn't actually work properly. So you can see we have a model, and I can push it. And if we have a look down at the bottom of the screen, we're getting some debug output. So you can see how many instances, 0 instances, 1, 2, 3 instances. And the pipeline had a specific number of instances it needed before it was ready. And now it will actually start training the model. And it will take a few clicks before it starts to learn the association. And you can see down at the bottom, at the very bottom, you can see it's still predicting on either side of 0.5, so it's not quite there yet. But now it knows. So I push hello, world, hello, world, hello, world, which is the sequence. Now, if I change the sequence and I just push a whole lot of hellos, you'll see it first off, it thinks I should push world next. And it still thinks I should push world because that's what follows after hello. But after I do this a few times, you'll start to see, oh no, actually now it's expecting me to push hello next. But if I do world, and then hello, it will go back to expecting that. And you can see it learned quicker the second time that I was going to push hello again, because it's learned that as the association. And that's part of the interactive. So this model is very simple. It knew absolutely nothing before we started pushing those buttons. And just from that few little clicks and not very many iterations, it's learned that there's a sequence, hello and world, and they'll follow that. Now, you could see at the bottom that it's 0.738, 0.189, etc. And as it learns and as you become more predictable, those numbers will become more precise. So that's very simply how you would do it using the drag and drop function in Design Studio. Now, if we just have a quick look at what that's actually generated, this is the QML. And the QML is like a scripting language for controlling the markup and doing the layout. And you can see it's very, very similar. It's a tree structure type language. And you can see we've got a model, we've got the values going into it. Everything that we set on the right, you can set here. And actually, if you change the numbers here, it will actually update what's going on the screen as well. So you can see now it says lag of 5, lag of 7. And then you've got the buttons, the fact that they are setting the value through to it, and then the prediction and the result. Really, really simple. Right, so that's what it would look like in Qt Design Studio. Now, this is actually an interesting demo for another reason, and that's because it's actually what we use for our demo site. So if you were to go to demo.ekkono.ai, you can play exactly the same game. Now, this has a different pipeline and a different model. Obviously, the person who made this is slightly better, considerably better at their design and styling guideline, but you can see it works in exactly the same way. This is also by default using a random forest. But what it's doing is it's actually predicting what your next button is likely to think. And it's saying, yeah, actually, you're pretty predictable. Should be very predictable, seeing as I'm pressing exactly the same thing. If you do this long enough, it'll actually start to tell you what the prediction is. And you can go into here and you can play with different types of models, different settings. You can get some information about how they work and what they do. So loads more information. But let's just have a quick look at the code that's powering this. So this is the Python code that is powering this. It's a little bit different because it's a piece of stateless code which has some state passed into it. And that state is passed into it in the input data array. It's as it says here, it's a string with various different values, 100010, depending on what button you've pressed. And it puts this through to the model. And you can see it's doing very much the same thing. So we've set up attributes. This attribute is our input. We've got a target. In this case, it's called target. We're saying we want 10, we've got horizon 1, so very much the same. We load our data into the previous history. This is because it's not learning every time you push it because it doesn't store any state. So we're actually building this model every single time you push that button and then discarding it. So every time you push it, it takes that thing, it trains up a whole model, and then it discards it. So it's actually a good way of showing just how efficient it can be to do that. We're doing the same thing with the lag and the backwards moving average. Actually, he uses different ones here. He uses deltas and backward moving average to achieve the same thing. We set up statistics. That's something you don't need to do in the QML. You can do it if you need to do it. It's actually in not for lags, but in here, you can go in and you can adjust the statistics. And our different models have a different requirement for statistics. It's using an MLP model in this particular code example. That's a multi-layer perceptron model rather than a random forest. We then train it on that history, do a prediction on the last value that's been produced, do exactly the same thing, that's rounding it if it's greater than or less than 1, and we return the result. So you can see that's pretty similar types of code to what we've been doing, but written in Python. Now, if you start to go crazy, the number will go down, but eventually it will go back up again. And I can assure you that both Chris and I tested to make sure that if you used exactly a sequence of random numbers, the accuracy was 50%, and surprisingly it is. So that's kind of my two examples of Hello World. One is spelling it out, one is a bit more ones and zeros, but it's quite cool. But I want to actually take a chance, seeing as we have a couple more minutes, and load up Qt Creator. And I'm going to open up another demo that we have just to show you. It's got a visual demonstration. This is also using QML to do the graphing, but what it's going to show you is how we can predict off of a sequence rather than just a couple of button presses. So we'll just open up my graph demo here. When I ordered my laptop, I wasn't planning on doing so much coding, so it's a little bit on the slow side for this, but that's okay. So this is another QML file. It has quite a lot more code in it because it's got a timer and it's generating data and adding graphing points. But you can see that the actual model and the predicting and all of that is very similar. So this is setting up a target horizon. We're going to stop training at 160 iterations. So that means the first 160 will feed into it. We're using an MLP model with some custom parameters. So this is your what size batch it's going to learn on, how quickly it will adjust its learning, number of iterations, etc. We are going to do an evaluator to calculate the error between the predictions and the values that are actually being sent into it. We're also going to run a change detector. And we have a really, really simple pipeline. And this pipeline has just got one attribute and then a lag, which is 2 values in the past. You can see here that we've initialized some statistics. And then when a prediction is generated, we're going to add a point to the graph. Got a few more display information here, and then there's a chart down at the bottom showing different values. But let's just run it. You get an idea of what it looks like. And you can see it is running. Now, we have a couple of different lines. The blue is the input signal, the orange is the error, and the green is the predicted value. And it's very simple. It goes from 0 to 9, and it just keeps repeating. And you can see how quickly it has learned, 40, 50 iterations, it's already getting pretty good. By 100, it's very good. And the error is very static. Now, this purple line kicking in is the change detector. And what it's going to show is at 300, at iteration 300, we've changed the input value by 0.01%. No, by 0.1%, my apologies, it's 1.01. So all of the numbers have been adjusted off by 1%. And you could see it, just about see it in the graph on this one here. And you could see that the moving average error changed a little bit, but actually the change detector picked up quite a big drift in the model and went, whoa, hold on, this is no longer the model that you changed on, which is tying back to the very first demo. So this is a really simple example of how a model can train quickly and efficiently without using a lot of knowledge or background information. As I say, it's a completely simple example, but you can see just how simple the code is based on this. And the C++ code will be very much equivalent to this because the mapping between QML and C++ is very straightforward. So that's kind of my 2 different languages and a very simple demonstration showing some training. I think the best thing we can possibly do is have a little stop and see if any of you actually would like to ask any questions or make any comments or anything like that. And I see absolute silence. Come on, Chris, you can ask me a question. I know you want to. Cool. Simple. I like that kind of demonstration. So let's go back into PowerPoint. We have more stuff happening on our website, on LinkedIn, Facebook, Twitter, Instagram even. There'll be another open feature coming up very, very soon. This is in 2 weeks, same time, same place. And this will be on how to get started, a bit more information on what you need to know and where that's going. I'm not going to say too much because Joachim and Robert might get upset with me, but I'm pretty sure based on what I've talked to Robert about, that it's going to be pretty interesting and a really great way to help you get your mind around what you would need in order to make a successful machine learning in your IoT project. Thank you very much for listening, and I hope you all have a wonderful afternoon.